In this lesson, we're going to look at more examples of using the enthalpies associated with phase changes in problems. What mass of NH3 can be vaporized with 125 kilojoules of heat? Enthalpy of vaporization of ammonia is 23.35 kilojoules per mole. In this problem, we're being asked for the mass instead of given the amount of substance. We're given the amount of heat and the enthalpy of vaporization. These are still dimensional analysis problems. I'm still going to look for the simple unit to start with. In this case, we're going to start with 125 kilojoules. We know that kilojoules needs to go on the bottom of the next step, so we give the value that was included, 23.35 kilojoules per mole for the enthalpy of vaporization. Kilojoules will cancel out. Next, we need to put moles on the bottom so that we can cancel out moles, and because we want to get to grams, we're going to need the molar mass of NH3. The value of which is 17.03. Now we can cancel out units of moles, and when we solve the problem, we end up with 91.2 grams of NH3. This is a vaporization process, which means energy is being consumed by the system, so it's an endothermic process. And this explains why we have a positive value for the energy. How many moles of ice can be frozen when 85 kilojoules of heat energy is released? The enthalpy of fusion is 6.01 kilojoules per mole. So we're looking for moles, we're given the amount of heat energy, and we're given the enthalpy of fusion. Remember that fusion is melting. Note that it also tells us that that is the amount of energy released. The change in energy for this system, therefore, will actually be minus 85 kilojoules, because the change would have a positive or negative sign to determine whether energy was consumed or released. Since energy is released, we know that the value must be negative for the change in energy. However, when we do our calculation, we can ignore the negative sign because it would give us a negative value for moles, and neither moles nor grams can have a negative value. We start with our simple unit, which is 85 kilojoules. We're going to use the enthalpy of fusion because it has the same numerical value as the enthalpy of freezing. So we have 6.01 kilojoules per mole. We can cancel out units of kilojoules, and then we get 14 moles of ice. What is the energy change when 1.8 moles of methanol is condensed? The enthalpy of vaporization is 38.3 kilojoules per mole. So we're being asked about the energy change, and whenever we're talking about energy change, we need to determine whether the value will be positive or negative. We have 1.8 moles of methanol. We're undergoing condensation, and we're given the enthalpy of vaporization is 38.3 kilojoules per mole. We start with our simple unit, which is 1.8 moles. We know that moles needs to go on the bottom, and the top will be 38.3 kilojoules. However, remember that this is a condensation. As a result, energy is being released by the system, making it an exothermic value, so it must be negative. So we have minus 38.3 kilojoules per mole. We're given the enthalpy of vaporization. The enthalpy of condensation has the same value with the opposite sign. Units of moles will cancel out, and then we can get minus 69 kilojoules is the energy change when that amount of methanol is condensed.